Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Step 1 says to set u equal to the expression raised to the power. As we've discussed, if there's ever any doubt about what u should be, at least in the context of the problems that we're dealing with now, you should choose the power of x that's higher. So in the numerator, you've got a 4th degree expression, and in the denominator, you've got that x to the 5th plus 1, which is a higher power. So that's your best choice for u. Just a rule of thumb, but it's going to get us through this until you get better at understanding what's going on. Right now, we're just trying to get off to a good start. So we choose u to be x to the 5th plus 1. Step 2 says to compute du dx. That's the derivative of u with respect to x. So that would be 5x to the 4th. Step 3 says to solve for dx. So I'm going to multiply both sides by dx. On the left, the dx is divided out, and I find out that du is 5x to the 4th dx. But remember, we're solving for dx. So I need to multiply both sides by 1 over 5x to the 4th, so that the 5x to the 4th divide out, leaving me with just dx. Remember, I'm trying to solve for dx. Well, if I do that, I've also got to put a 1 over 5x to the 4th on the other side of the equation. And when all is said and done, I know that dx is equal to the fraction 1 over 5x to the 4th multiplied by du. Step 4 says if the integrand has a numeric that is a constant factor, move it outside the integral. And here you see that there is a factor of 3 that you can move outside of the integral sign. Step 5 says substitute both the u and the expression represented by dx into the integrand. Just a simple substitution. Remember though, you've also got to carry that 3 along. It's not doing anything right now, but you have to carry it along because it will multiply through in the end. So we're physically taking out the x to the 5th plus 1 and putting u in its place. And for dx, we're removing it and putting in what it's equal to, which is the fraction 1 over 5x to the 4th multiplied by du. Now we want to simplify the integrand. The first thing I hope that you notice is that there's an x to the 4th in the numerator and an x to the 4th in the denominator, which will divide out. You also notice that there's a 1/5 left as a factor inside the integral, which can also be moved out, and it'll eventually multiply by the 3. All that leaves inside the integral is a 1 in the numerator, a u to the 3rd in the denominator, and the du on the end. Look at that very carefully because this is important. You can also clean it up a little bit by noticing that 3 times 1/5 is 3/5, and that 1 over u to the 3rd is u to the minus 3. And the reason I want to write it that way is because I'm looking ahead. I know I'm going to use the general power rule for integration, and it tells me how to integrate u to a power. So that's why I want it written that way. Speaking of that, the 3/5 is just going to follow along for the ride, but we need to use the general power rule for integration to evaluate that integral. The general power rule for integration tells you to integrate u to a power, you add 1 to the power. Adding 1 to a negative, be very careful. Minus 3 plus 1 becomes minus 2, so it becomes u to the minus 2. But then you've also got to multiply by 1 over that new power. So 1 over minus 2. In other words, a negative 1/2. And as always, with any indefinite integral, you have to add a plus c. We can clean up some of the arithmetic. Multiplying those two fractions, top times top, bottom times bottom, a positive times a negative will end up being a negative value. So it's going to be negative 3/10 times that u to the minus 2 plus c. And at the end, you're just going to substitute the x values back in because we put the u in. The u was not in the original problem. U is equal to x to the 5th plus 1. So we put the x to the 5th plus 1 back in place of u, and we're done. And keep in mind, if you have any doubt that you got the answer right, All you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right.